different point of view to look at things, okay? Then we can find out what is back table, what is dimension table, and then what is foreign key, and how to do normalization. Now we keep moving on. Now we would like to watch a video about 5 minutes talking about what is OLAP. We watch first, then we explain later on. Yeah.
踏出第一步，让 GoDaddy 将您的生意在线上发扬光大。在我
Welcome to this eCapital Advisors video on OLAP data modeling concepts. OLAP is an acronym for online.
The voice is
Welcome to this eCapital Advisors video on OLAP data
the
modeling.
voice is yeah.
OLAP is an acronym for online analytical processing. It is an approach to analyzing data from multiple perspectives. It utilizes components called dimensions, measures, and cues. A cue is the end result of a data modeling exercise. Cues can hold data, collect data, and calculate data. Cues align to view data in many different ways very quickly. Cues are made from dimensions. Dimensions are lists of related items, such as products, time, or regions. These dimensions can be combined into cues. You can imagine what two dimensions would look like by using a spreadsheet metaphor, with the time dimension as the columns and the products dimension as the rows. If we add data to this view, such as units sold, that will be a measure. Measures can be any quantity, such as revenues, expenses, units, statistics, or any text or numerical value. If we consider adding the third dimension, regions, then you can imagine each region being represented as an additional spreadsheet. This is how it works when you're limited to a two-dimensional spreadsheet. However, an OLAP cube can represent all three dimensions as a single data set, which allows users to fluidly explore all the data from any perspective. And despite its name, a cube can hold many more than three dimensions. So what's the value of using OLAP? To illustrate this, let's pretend that you are the manager of multiple stores. Let's say that you're tracking sales units with three different spreadsheets with three different dimensions: products, orders, and regions. From looking at these spreadsheets, it appears that everything is equal. As a manager of these stores, you would probably stock them with the same number of items for each product, order, and region. But let's see how that assessment can change by combining just two dimensions. Here we have a two-dimensional report that looks at units sold by product and by quarter. We're using the same data as in the last example, but now we can see that product D does better in the first quarter, product C in the second quarter, and product B in the third quarter. Based on this new analysis, you would stock your stores differently. Now, let's look at a report with three dimensions. Just look at the difference a third dimension can make. We can see that in the West, only product D is selling. In the North, product A is the most popular. The South likes product C, and product D is selling the most in the East. So based off this information, you would probably make very different decisions than you would looking at a report with just one or two dimensions. You could continue to add more dimensions and reveal more detail, which would allow you to make better decisions on managing the inventory of your stores. So what would this look like using an OLAP cube in practice? In IBM Planning Analytics, we have the ability to view OLAP cubes in Excel. You can see we have the same data for our products. We also have three other dimensions available, which are represented by the boxes in the exploration bar. If I want to add a second dimension, quarters, to my view, I can just drag it to the columns. If I want to add the regions dimension to my view, I can drag it to either the rows or the columns. For this analysis, I'll nest in front of my products, which are in the rows. Now I can see a much richer view of my data. I have a fourth dimension for actual, budget, and variance versions, which I can also nest in my rows. Now I'm able to compare the differences between my actual and my planned inventory by order, by region, and by product. To reorient my view, I simply drag the dimension from rows to columns. With OLAP, I'm able to do a much better analysis than I could with just 2 spreadsheet dimensions. If you're interested in learning more about how OLAP can help you do better analysis, feel free to contact us at eCapitalAdvisors.com, or you can reach me directly at jleahy@eCapitalAdvisors.com. Thank you.
So this is the OLAP. So how about we have a break now, so we continue to do this part because it's different one. Okay, so we have a 5-minute break.